Good afternoon, everybody. Thank you so much for being here today. We want to welcome you to the DCU FinTech Innovation Center and to Boston FinTech Week. So you guys probably already know about the week through signing up, but really what it is, it's a collaboration of Boston's finest organizations that support FinTech initiatives. And it was originally created, the idea behind it was created by Sarah Biller of the Boston Meetup Group, and set together in collaboration with the FinTech Sandbox, who's housed here, and us at the DCU Center. We've put together this week, and we're very proud to be able to house events like this, including creating them with member startups, folks like Greg, who you'll hear from later today. The DCU Center, for those of you that don't know, is a sole-sponsored accelerator program for C-stage Boston FinTech startups. We have 18 companies in the space. It's sponsored by DCU. We've got some execs in the back right there who are all hanging out. And so I'm going to hand it over pretty quickly to our moderator, Raj from BC. He is an AI and machine learning expert with deep experience across industries in the space, and I'll let him take it from here. Thank you.
Great. Thanks, Vasily. Thanks, everyone, for coming. Appreciate it. Again, thanks to DCU and the Boston FinTech group. Sarah and Gene are fantastic. I'm glad we're doing. Can everyone hear me?
I don't think it's on.
I don't think it's on.
Testing.
All right.
Getting closer, right? And so it could project. So thanks again for coming today. Okay, my name is Siraj. I teach machine learning at Boston College. Spent a lot of time in the financial industry as Eaton Vance's CIO at Boston College's, the Boston Company's CTO at State Street Global Exchange, creating smart data aggregation. But also with startups like Endeca and others in the healthcare and financial industry field. So I'm happy to moderate this panel. The objective here is really to talk about AI and its application, its real application within the financial industry. So it's a little bit of a mystery, who's really doing it and where. So hopefully we'll shed some light on that. What I wanted to do is introduce my esteemed panelists. Greg Woolf, CEO of Coalesce, and Louie Balasny, from Managing Director of BotKeeper. So I'll let them introduce themselves a little bit. We have a little presentation that we're going to go through, but we're going to interject it with questions. I'll ask some questions, and if you have any questions, I'll try to moderate questions from you as we go through the presentation. And if we ended up having a discussion on a particular point and everyone's getting value from it, we'll just pause and do that. Okay? Sounds good? Okay, good. So to you, Greg, or you know, Louie.
Can you guys hear me if I speak like this?
Yes.
Yeah, that'll work. So I'm Louie Balasny. I helped start, and I'm the managing director of a company called BotKeeper, which is a machine learning company specifically in the bookkeeping and accounting space. We are a better, faster, cheaper bookkeeper by blending machine learning with actual accountants to do the work of a traditional part-timer, or just a better job of a traditional outsourced accounting firm. My background is actually legal. I'm a Boston native. I went to Suffolk Law School. I hated law school. If there are any lawyers here, you probably understand what I'm saying. But I spent some time in the estate planning space, the insurance planning space, and even some banking space. So there's a ton of attributes, and we'll get into this later about why machine learning is awesome in that space and in general. But that was where my background was, just a lot of inefficiencies. BotKeeper was sort of a spawn of that. And bookkeeping is also really boring. So I'll do my best to make it really fun. I'm going to pass it over to Greg.
I'll take the mic. So my name is Greg Woolf, and as Vasily says, we're one of the member companies here at DCU. So just a shout out to DCU. Thank you for having us as a member and hosting this event. It's really been a terrific environment for us to cultivate our company and grow our company. It's been very helpful being here. That said, so my background, I'm from South Africa originally, in case you were guessing about the accent. And my entry point here was PwC, and about 15 years ago I started a company which developed software for operations software for alternative investment managers and private equity, venture, real estate type asset managers. And our client base in that space grew to over $1 trillion under management, and we're very much focused on quantitative analytics in that space. And about 3 years ago, we had an idea of, well, wait a minute, how can we use this new technology that's coming down the pipeline, machine learning, natural language processing, artificial intelligence. So we created a new product called Coalesce, and we realized that was a great opportunity and spun out as a new company, and here we are today.
Sheldon. You wouldn't mind, so, yep. Louie and Greg. So, should we fear AI? I'd love each of you to talk about this, right? So there's a lot of hype about this. First of all, from a terminology standpoint, we're not going to do the purest terminology thing, AI, machine learning, deep learning, you know, the hierarchy. But for purpose of today, we're just going to call it AI because that's usually what people are interested in from a buying perspective, from a marketing perspective. But I'd love for each of you to talk about this hype and piercing it.
Great, thanks. So the hype around AI, obviously very exciting, but fraught with a lot of fears. Here's a couple of interesting slides. The one on the left is a mall robot. That's one of these automated, self-driving mall robots, and it ended up committing suicide by plunging itself into the fountain of the mall. So it doesn't always work, right? And I'll let Louie speak to the middle one, but the one on the right is one of my favorites, and that is it's an online game where they gave the same skills and power to the kind of the bad guys in the game, which are AI robots running around. They gave them the same skills as they gave the players of the game, and the AI completely dominated and went around and started shooting down and destroying all the players in the game, and they had to go in and fix it.
Paying players.
The paying players, exactly. So you know, these are kind of anecdotal, but they do show that, you know, that there is some risk around that, and that's a whole separate topic. But we're going to focus on today is more around how are people using it today, and what our interpretation of AI and machine learning is, and how it's being used in FinTech environment.
Yeah, and then I think the other thing people think is that they're actual bots. So bots are being built with this AI background that are taking over people's jobs, sitting behind computers, or just standing around doing a lot of this coding or this planning. That's not the reality. I know bot is in our name, but it's not because a robot is coming into your office and doing your books and looking at your QuickBooks and checking your bank accounts and all that. It's all software driven, so we'll get into that. But don't worry, Ultron's not coming, Terminator's not coming. There are no bots.
We're safe for a few more years, right?
At least for now.
That's good. So let's talk about why now, right? Because I studied, machine learning when I was ages ago in graduate school. Did research around learning by analogy. There are different modes of neural networks, up and down, the AI winters, etc. But why now? Let's just pierce that first.
Absolutely. Thanks. And when we got the vision for this potential of machine learning 3 years ago, there was a ton of skepticism on it. Some folks might remember the AI winter of the 80s and the 90s. Anybody know what I'm talking about here? So, yeah, thank you. Especially anybody who was involved in investing in those days. And I think even the last 3 years, it's been a journey. And as we were building out our product, we faced a lot of skepticism. But I feel the turning point was at the beginning of this year, and I call that the Alexa moment. So Siri has been around since 2010, Watson 2011, Google's self-driving cars 2014. But I think when Amazon created a device that they put in our living rooms and our kitchen tables that people could relate to and speak to and say, wow, that's actually interesting. Alexa, what is the capital of Turkey? What's the weather going to be like tomorrow? And engage Alexa in part of their kind of conversation. That's kind of pierced the veil and broke the ice. And since the beginning of this year, I feel that it's gone the other way now. The expectations about AI are actually unrealistically inflated. So, but that was that kind of moment where people looked at Alexa and said, that's interesting. How do I get that at work? That could really help me in my job.
Yeah, no, that's absolutely right. I think now that it's become so much more mainstream, I think people are completely over inflating the use for it. But go ahead, sorry. I think it was a good segue to this, but I think just
Yeah, the key here is this is the financial industry. So I like to think of the financial industry in several buckets. You know, banking, insurance, asset management, and asset servicing. It might not be complete, but so I'd love to hear your thoughts in terms of where are we seeing the action.
Yeah, I mean, just on the numbers there, you can see every sort of the expectations over 5-year periods is just insane. And that's just attributing to kind of basic tasks that people are doing now that they're doing either inefficiently or just not actually recognizing what's going on. So in research, in investment, in customer service, in data entry, right? There's just so much more that can happen with applying machine learning, and you're seeing this sort of happen over the market.
I think the only thing I have to add to that is the potential. We're out raising a round of financing right now. When we chat with investors, they consider this the equivalent of mobile and cloud. And if you think about, I mean, cloud is pervasive today, right? We don't even think about, wow, would I have my data out on the internet, not on my laptop or my desktop or servers? But if you think about the early days, there was a lot of resistance and a lot of progress needed to be made until marquee players like a Salesforce came in and made that kind of pervasive and mainstream. So the potential is equivalent to mobile and cloud, which are here to stay. This is not a flash in the pan, and we'll tell a little bit how we're seeing it working.
So I see here research analysis, investment advisory, customer service. Are there particular use cases you could talk to that you could share with the audience here that you know of?
Yeah, I think so. I guess for us, we're kind of dabbling in the research-ish space. So what we're doing is more of allowing more accuracy with decision making for certain inputs. So we're grabbing a bunch of data from systems like your bank, your credit cards, payroll, all that stuff, running it through decision trees, creating rules based on historical data, right? Not being predictive, but looking at what's happened in the past or accounting standards, and then outputting it that way. And then that also helps kind of down the road with just sort of mitigating a lot of risk, right? There's less decision fatigue. You're not kind of worried about getting tired. The decisions are going to be consistent. It's binary. So I think we're probably more in that space, but it's happening just not just in the bookkeeping space, but all across.
That's great.
Yeah.
Well, I thought maybe I'd start out with describing what we mean by AI and machine learning, and then give some exampps. So we want to lead into the next one.
You want to go to that? So later.
It's later.
Correct.
It is a little bit later.
So yeah, if I can take that thing. Raj started out with the comment of, there's this mystery around AI, and I think the biggest service we can do for the community right now is to demystify it. And although not technically, academically pure, I think what I'd like to give you is our idea of being in this space and working with clients and having people actually use this in terms of what we mean by machine learning versus AI. And this is the hierarchy of data. It's like Maslow's hierarchy of needs applied to data and information. I'm sure you've seen this in other contexts. And where we're seeing, so data, let's take a customer service example, right? A piece of data is an email. Information is a relevant email that may contain some keywords. This is where technology was prior to AI machine learning. Knowledge is where the machine starts to understand those keywords in context. And what we mean by machine learning is the machine can learn from a business user to replicate and reproduce their analysis of whether it's an accounting transaction, or in this case, a customer service email, and filter that information based on their understanding of that context. So that, we call that machine learning because the machine is learning to do the job on behalf of a person to free them up to do more interesting stuff. Wisdom, we consider this the artificial intelligence layer. So this is a point where, and this is going to take some time, where machines are able to, once they've learned from the humans how to do the job, the humans will be able to go to the machines and say, okay, a computer can see so much more information than a person can. What kind of insights and predictive capability can I as a user start to extract from the system, advised by the computer, as opposed to things that I may have thought of myself? Realistically, where we are in the market is, I think, knowledge, machine learning, very much in place, happening today. This next paradigm of artificial intelligence, the system actually providing insights and predictive capabilities, it's something that we're all formulating and working on. But I also think that the market itself is not necessarily ready to trust that. So people are not necessarily ready to come in, look at a black box and say, well, the computer said I should make these trades, or respond to these customers or not. So that's where we kind of see the differentiation.
So it's interesting. So when I talked about machine learning, it's a set of techniques. Many of them have been around for a long time in terms of taking a problem statement, mapping it basically into an optimization problem, and finding the solution and then mapping back. So that's part of the demystification. If you look under the covers, it's really an optimization problem, mapping and solution. And this new technique of neural networks, these magic black boxes that seem to, the learning part is really finding the right weights within the neural network that kind of replicates what the desired output is, right? So in some sense, this new technology or this new wave of machine learning has made it cheaper to perform prediction. Prediction is becoming cheaper, and hence many organizations are trying to find areas within the financial industry that have to do with prediction and adopting this technology. Is that how you see it as well? Are there particular examples of that we could dig into a little bit deeper?
Yeah, definitely. In fact, good cue to the next slide, I think. So these are the kinds of problems that our product is helping clients solve. So let's take a investment risk. That's a good one. There's multiple layers to the machine learning and the prediction capabilities. So for instance, we have a client, they're a $60 billion investment firm out of Europe. And their challenge is they're invested in over 10,000 companies at any point in time, directly or indirectly. And they have a team of 20 analysts who are out there scouring the news, looking for bad signals that could be potentially risky based on their mandates and what's important to them. And some are obvious things like legal and corruption, but some of them are more subtle, like environmental problems, right, or labor issues. So the analysts over there typically look at 1,000 companies every quarter, and they use a sampling methodology based on their risk understanding to sample which companies could be potentially problematic, and they profile 1,000 companies per quarter. Using the product, so that would be, let's say, 40 to 50% coverage a year. Using the product, we're profiling 10,000 companies a week. So we're doing all of this every week. So back to the context of machine learning versus AI. So the machine learning piece is the analysts sit down and they teach the system, I'm looking for certain signals from the news about companies, and this is what's relevant to me as a user, and I'm going to flag what's relevant and what's not relevant, and the system gets better. It's like doing a Google search where you can say this is right and that's not right, and the system learns and gets better over time to personalize to the user's knowledge. To me, although maybe not academically pure, that's my interpretation of machine learning. The machine is learning to do a job on behalf of somebody, including their domain expertise and institutionalizing that into the software. The predictive piece is stepping back and saying, okay, here's some companies that had some real financial difficulties. The system is now able to understand the kind of signals leading up to that. What other companies are exhibiting similar signals? What pattern that we can get predictive and say, these companies are starting to kind of go down a path which is similar to a number of companies that have some real problems. We should pay closer attention to these companies. So that's how we differentiate between the machine learning, which is much more tactical, and the predictive capability, which is much more strategic and looking to the future.
Can we do the next slide real quick?
Yeah, sure.
So I think it'll help me too, and probably help kind of visualize for you guys. So we're kind of piggybacking off Greg in that tactical space, like really right here. But if you think about it, right, perception, or when you're plugging in the AI or the machine learning, is what data points you're going to work with, right? So like syncing with a bank, syncing with a timesheet management system, and collecting all those points. But then what, right? So just understanding like, okay, this is the space I'm going to be in. And then creating notifications around certain things I want to see. So it's scrubbing those data points, it's looking for X transaction, it's looking for Home Depot, and then sending me an email saying, cool, I found these 7 Home Depot points. And then on top of that, building out now what to do with those Home Depot things. So then kind of getting into like, if X, then Y type statements. So if Home Depot, then categorize it as office expenses. And you can kind of like build kind of deeper sets and kind of get 3, 4, 5 dimensional, like Home Depot might be a slew of different things, but start kind of coding around there. And then the automation point is being like, okay, it's always going to be this, right? Home Depot at $500 is always going to get categorized as this. So I'm kind of putting it into what the bookkeeping and what we're doing and why it's sort of quicker. But we don't get past that, right? Because once you start getting in the prediction space, you're dealing with company financials. I've been paying a part-time CFO over the last 4 months X amount, but we stopped working with them for month 5. If it was purely prediction, and this is like really, really simple, but I might send an invoice, or I might send a check out to the CFO on month 5, and I wasn't supposed to. So we stop at that point, kind of put some human kind of overlay just to make sure this stuff is right. But going back, we're coming in and we're helping kind of shift the output, right? It's not like AI's not coming in and doing the decisions for us or like worrying about, this sort of like melee of things that we have no idea what's going on. So as long as you're kind of shifting and kind of putting the data in that you want to see, it's a really kind of efficient, beautiful tool. And then for the knowledge and the wisdom, that's more of the prevention, situational awareness, like AI getting into that deeper stuff, but we're not there. But that's sort of the progression. I don't know if that helps you guys kind of see it a little better.
And just to add to that, I mean, the we're not there, we agree with them. The majority of traction that we're seeing over here is that workflow automation and scaling. We're a little bit more on the machine learning models in terms of teaching the system to learn something that may be subjective based on user knowledge. The prediction, everybody's keen to see it, but I don't think we as a society are there to trust that yet.
Yeah.
I don't know, how many of you would trust a piece of software that would tell you in the morning what your job should be and make coffee?
Could we go back just one slide?
Sure.
Please? So I love what you said about one use case, which is around the risk there. In some sense, let me see if I could paraphrase it. It allows one to do much more with less, right? So allowing 100% coverage instead of whatever, 10% or 15% coverage for certain things. So is it as simple as that this technology allows us to do so much more of the same, but so much more of the same? Or are there use cases where it enables us to do things that we literally could not do before, or are surprises? Have you run into any of those examples?
Yeah, I mean, without a doubt, last year the Obama administration came out with a terrific publication called The Future of Artificial Intelligence, and it was written for Congress, i.e. not very technical. But not preschool, that was big. And they characterized this whole AI revolution really well, and they describe it, I think, as kind of like as an industrial revolution. So it's the modern equivalent of getting people out of the fields where they're using shovels and picks to driving tractors. And then that brings in a whole lot of questions around what is the social impact, and I actually moderate a number of meetup groups in Boston. We have about 10,000 members across the different groups, and we had an event about a month ago in partnership with PwC talking about the social, legal, economic impact of AI and automation. So there is some video if anybody's interested to hear that, but that's a whole separate conversation which we're not going to address today. But that does bring in some of the questions here. So the answers are, certainly the systems are proving that they can do this work. At some point in the future, we're going to be able to rely on these computers to do things for us and come up with insights. I know there are folks out there that are large drug companies that are using machine learning and predictive capabilities on a very technical, molecular, quantitative measure to see if they can mathematically come up with cures for different types of cancer, which is not that different from the robots inside the game that figured out how to game the game and shoot the humans and beat them. So it's doable, and I guess the second conversation around this is we need to just think about generally, what does it mean for the risks around this, like weaponized AI, and how much power we're prepared to put in charge of these machines. I personally think the biggest risk is things around our dependency on the software automation without transparency, without being able to see why the computers are making these kinds of decisions. And that some piece of code or some weighting in a neural network could have a drastic effect, like switching off all the traffic lights in Boston for an hour, or switching off the electricity grid.
Great point. So there are a couple of loose ends there. There's social impacts. There's the data behind it and the biases that I want to address a little bit. Well, let's start with the social implication and then prepare some questions, guys. after this answer here. So could you describe, for example, a use case that you're using for automating accounting through your technology, and what that's meant for the people involved? And has it been positive or negative? And what happened there? And perhaps if you could help with a similar use case.
Yeah, so I think in general it's been positive, because what it's allowing people to do is focus more on things that are human, right, versus getting caught up in data entry or sort of boring, mindless blocking and tackling. So Boloco is a client of ours, and they've got shops all over Boston. They love consistency, right? Their shops function the same way. They're making sales. They want to be able to track that stuff kind of behind the scenes consistently. But when you have someone kind of running each of the shops, or one person bouncing around 4 or 5 places, they're going to get tired. They may overlook certain things. So for them, it allows, the GM or whoever's kind of keeping tabs on certain shops to not worry about the basic stuff. And then on the back end, it allows for consistent output, so they know every month they're looking at the same stuff and nothing's wavering. So from a pure kind of decision-making perspective, it's smoother. It allows them to not really worry about, man, did I do this wrong or did I do this right? And it just frees them up to do more things that they want to do.
Yeah, to add to it and reinforce that, I think the areas where we're seeing the most traction are risk management and operations automation, which is what BotKeeper does. So we spoke about that one. I think the use there is kind of obvious, right? Who wouldn't want to check everything instead of sample testing? I think anybody can relate to that. This is an interesting one. This is where we can, and it kind of segues to the last slide in a second, but so we have a client, they receive 6,000 pieces of paper every month, right? That's exactly what it is. It's a financial investment firm. And they have a team of people manually, actually they don't get paper, I guess they get emails with PDF attachments. And they have a team of people manually going to the email inbox, identifying, is this the right email, what's the context, pulling the PDF document out, saving it in a client folder, and then opening up that PDF document and extracting some information. Some of it is qualitative, some of it is quantitative, like performance data, and then pushing that into a database and doing aggregated reporting for their client. So it's a heinous job, and it's difficult and it's risky. So senior management is looking at that, saying, we're burning through people just doing this manual work. And the people doing the job are looking for some means to get some coverage, which makes it easier. So I think back to your question around data, one of the things that we're seeing success in this space is that the availability of different types of transactions, different type of data that the systems are able to parse and replicate in a machine learning fashion. So for instance, risk management is all about going externally and pulling 50,000 news articles, news from 50,000 outlets a day, scanning that through some user-defined algorithm on the fly to filter that. But this workflow is around patching into an email system, pulling a PDF document out of that, processing that just like a human would, and then extracting some numerical data. So those are kind of the data and the use cases where we see people are getting a benefit from it. From a senior management perspective, they feel better because the job quality, the hiring practices are much strengthened. They're offering better opportunities for their employees. And from a risk perspective, and just it's not always about the bottom line, although certainly this adds to the bottom line, right? But it's not always about the bottom line, it's about a lot of the risk and qualitative factors that may fit along with that.
So I love some of the presentations about blockchain. I think from my perspective, it's a little bit farther out in terms of its impact, but I think machine learning has a much more immediate and medium-term impact on changing the game. Do you agree or not agree? Questions?
So you guys talked a lot about automation. Oh, sorry. Can you hear me? So you talked a lot about automation and deterministic logic and looking at the risks associated with those types of technologies. I mean, as we're making the next step towards these type of predictive, non-deterministic algorithms, how in the context of financial services do you think that enterprises will be controlling unset risk or unidentified risks, and what are the risks that you would see around those types of tools?
So So let me rephrase. Using the techniques of probabilistic
Yeah.
approach for machine learning versus the neural network approach, is that what you mean?
Exactly.
And how well received would a new approach be?
And almost how do you rationalize the risk in context of that new approach?
And how one rationalizes the risk?
So, sorry, when you mean a new approach, explain a little bit more about the nuance there.
So I'm really saying in regards to the hierarchy that you described, moving from the point of automation and determinism to saying predictive, and we're now, we're not sure of what the outcome may be in the process, right?
Right. Yeah. Okay. Definitely. I mean that's the boundary where we are right now, and that is what we're finding is working. I mean, there's theoretical stuff that's been around for a long time. We have a guy on our team. He is in his 60s. He's written 25 books on AI and machine learning, and he's the first person to say to me, "Greg, these algorithms have been around since the 1950s, right? It's the abundance of data and the processing power which has made it real today." And I think from a risk perspective, I have another slide from another presentation, but we're adding the equivalent of 100 million cell phones worth of data every hour to the web, right? And a cell phone has a lot of information these days, right? So that's a pretty big number. And 90% of that content is unstructured. So it's not some convenient number you can pull out of a database. So from a risk perspective, I see that in the very near future, the amount of content that's out there when somebody's doing their job is going to be virtually infinite. Right? And having these virtual employees that are out there managing transactions, processing, looking for risk, I believe is going to be the only way that companies are going to succeed, because it's just going to be so voluminous for people. So there's the risk of not implementing this type of system. At this point, I would say the biggest risk to transitioning to this is transparency. Yeah, and calculating that boundary. And I can go off on a little bit of a tangent here around technology and stuff. But has anybody ever heard of the company NVIDIA? Okay. So they make graphics cards for gamers, right? You guys must think I'm some kind of computer gamer. It's two analogies in one presentation. When I was a teenager, okay, I admit, okay, I'm definitely a super geek. But that said, NVIDIA is actually now starting, one of the things that their graphics card is a huge enabler in doing these machine learning calculations, because to keep it simple, where a regular computer can maybe do 4 processes, 4 calculations each second, 4 million of these, a graphics card can do 2,000 transactions. So it lends itself to machine learning. So NVIDIA is becoming a real strong player in building out AI-driven hardware to power these kinds of systems. But NVIDIA themselves have recognized that neural networks, which are this massive set of matrices and complex math that no human being can look at in n-dimensional space and say, oh, I get it, I understand what's going on here. So they recognize the challenge around this, and they've actually started to build in some transparency capabilities which is allowing humans to take a look at some heat maps and see how is this car that's driving down the road, how is it identifying the boundaries? Why is it coming up with that determination? So I think that, from a risk perspective, is key, right? We need to understand transparency. And one of the things that we do, and why we're still in that machine learning phase as opposed to deploying the predictive stuff, we've got great prototypes and things, but realistically, we need to get people with a confidence level that they can actually say, the machine learned to do my job. I did it manually over here on the side myself, like I've been doing for the last 10, 20 years. And I'm looking at the results, and they're as good or better. And the better is generally because of coverage, not because of the insights yet. I'm now getting to a point where I'm really willing to let go. And one of the things that we have in our product is we have a confidence level. So if the system tells you, here's a company, here's the piece of news that you were looking for, we think it's bad news, and we're 75% sure about that. I think that level of transparency is critical. Long answer. Maybe you wanted to finish this.
I think this is a very important topic, and if you forgive me, Greg, I'd like to follow up on it, because with a two-part, one is an observation, and the second is a question. The observation is that part of your counter-argument that risk is reduced is that greater data volumes will be used. Now, I think it is possible that access to more data will give better outcomes, but it is possible that it won't. Either way, it is not provable. So I think it's a little simplistic to say we have machines that can handle more data and therefore we will give better results. So if you have something that can really take that towards provability, I'd love to hear about it. But I think it's first just an assertion that can neither be proved nor disproved. The second thing, and it's probably even more important, and I think it's part of the question you were trying to ask that hasn't really been answered, is most of the predictive methods that are available today are fairly black box. Yes, they can give a little sort of confidence interval, but they can't explain the reasoning and rationale behind it the way you as a CEO might ask an employee, why exactly are you recommending this course of action, and push and push and push and push. Instead, a black box will sort of give you, here's an answer with a confidence interval, here's another answer with another confidence interval, but you can't probe as to why. So how can we, as people responsible for making decisions, deploying this technology, assess the risk of taking recommendations from a system that is purely black box, where the people operating it, and probably even the people who programmed it, can't explain a particular decision the way an employee could explain the rationalization for a recommendation?
Great questions. One is about data and questioning the assumption that big data is good. I have to simplify it. And the other is about the black box aspect and how can we solve that dilemma, especially for neural networks, which change their weights and then do magic stuff but can't be explained, versus a decision tree based machine learning algorithm where you can see the logic behind it.
Fair enough. So, I mean, I think the question about is data, having an AI machine learning system in place will make you competitive, assuming there's data. What we're finding with the clients we're speaking with, it's inverted. They're coming to us and they're saying there's too much data. What can we do to cope? We can scale it up by hiring more people, but that's expensive and risky. So we're working in the space of the folks who have too much data. Certainly there's a lot of industries where that's not relevant, and a lot of jobs, especially around the more strategic side of things where it's not relevant. So we're focusing as a business on folks who have too much data. So I'm going to take that as a core assumption, right? Where we see the traction about the transparency happening is we're starting off with, and I think we're both starting off with, kind of low-level tasks. So when we implement with a client, we say to them, treat this like an MBA intern. This is imagine you just hired a really smart person from Sloan or VC or BU or Harvard, really smart kid. They've come in, they're millennials, so they're completely computer comfortable, right? But they know nothing about your business, right? So what would you do? You would sit them down, whether it's for investment research, whether it's for accounting, whether it's for risk management, whether it's for client service. You would sit them down with an expert, probably the manager of that group. And that person would say, okay, smart kid, I want you to go through this volume of data. It could be internal data in terms of transactions. It could be subscription data that they're getting from third parties. It could be external data in terms of just go Google it, right? I want you to go through this data, and this is from a business perspective what we're looking for. And here's some examples of what I like, and here's some examples of what I don't like. Now go ahead and spend 5 or 6 or 8 or 10 hours doing this and come back to me with your results. And that's the point where the human, and I love this slide, this actually came from Enrico, the CEO of BotKeeper, make humans more human, right? Everybody's trying to automate humans. No, we're trying to improve life for humans. But essentially that the ability to have a human oversee that process and say, you know, we can teach the system to replicate that along the same way, just like we would an intern. Think of it as a virtual intern. So the process of training the system is exactly like the process of training a person. You know, the MBA intern is going to come in, they're not going to get everything right the first time either. It's going to take a few weeks. But the advantage is, if the system that can learn to do some of these menial tasks, the advantage is, we're running out of time? 2 minutes, perfect. And then lunch. Right, I'm hungry. The advantage is that that when that intern goes back to school, you've now got a system that can replicate that process. And the next intern can come in and or maybe permanent hire can come in and take it from that level to the next step. So you're institutionalizing the domain expertise of the business users without the need of a data scientist to go out and program a system which is kind of monolithic. You're allowing a business expert to teach the system to do a job that then can just be expanded on.
Sure.
Take one last question.
Trying to end on a wet blanket in the room note, but the United States financial services regulatory system is uniquely complex. And a change in a rule can boost your business or kill it. Are there examples where AI is being deployed to interact with that system and interpret that, work with that for end users or anything that's coming up?
The SEC.
If you don't mind, I'd like to hand it to
Yeah,
Bob.
so I-
VP Sales,
Sorry,
David Oldham.
there was a,
Stand up there.
yeah, sorry. So there was an article published recently that was sent our way, and there was a gentleman who's the chief economist of the DERA at the SEC, and who spoke at a conference, a risk conference, just about a month ago, and we saw the transcript and we read through it. And basically he said they've been working on AI projects for the last 4 years or so, and they walked through their process and what they're using AI for. And specifically they're looking through transcripts, they're using different methodologies, they're trying different things to sort of find fraud in the system or risk in the system, right? So if the SEC is doing this work and they're investing heavily in it, I would think that it would be beneficial for the rest of us who are part of the industry.
Except federal regs aren't even all machine readable.
That's true. I mean, and that's going to be a problem for us in the business to sort of figure out how can we get more of this data and make it useful, provide it to you folks in a way that's helpful, right? So that's one of our challenges.
I think we're out of time.
Yeah.
Oh,
sorry.
So I'm going to ask each of you just to do a takeaway, and then we'll wrap it up. We'll have lunch and continue the conversation there. And thank you all for attending. There's so many parts of this that we haven't touched. Boston, Greater Boston is a fantastic area between the universities and the FinTech innovation clusters and the VCs that are very focused on this space. So I'm sure we'll hear more about it, and maybe we can do some future events. But what would you give as a takeaway to the audience?
Sure. I mean, I think to just kind of sum up what we said before, it's an exciting time. I feel privileged to be part of a community and involved in this kind of technology. And with cautious optimism, we should take a look at it and see can this work for us and make sure that it's doing something that's valuable for us. And I think this is the way business looks like.
Yeah, I think it's a way to basically work smarter and harder and do things that are, is that working? Do things that are just more relevant to you that you're better at than you're not. So look to maybe apply machine learning or just tech to things that you're really weak on, and don't worry about trying to make that smarter. But I think it's a really valuable tool.
I'll do one and I'll hand it to Vasily. Takeaway is look in your, for areas within your organizations, whether they're back, middle, or front office, that potentially could use this technology. A rule of thumb that I think about, or someone had proposed, is if it takes someone less than 2 seconds to make a decision, then that's an interesting area for the potential.